back of a Black Hawk. You have similar things on a Jayhawk, okay, and the Air Force has some other Hawk, right? But it's all the same Pratt & Whitney Sikorsky aircraft. So this one we cut it. I see. Yep, you can see the saw cut right down there. We cut it. This at the time that I was working on this, which was like early 1990s, so over 20 years ago. This was a $300 or $400 part, okay? But it's a pretty sophisticated part, and it matches up with this part, which if you, maybe I'll pass it around tomorrow. Well, I can probably pass it around now. The number of holes in this are different than the holes here. They didn't want to use a keyway because keyways cause stress concentration and fatigue. So the tail rotor of a Black Hawk or a Jayhawk or a Seahawk helicopter is just a conical fit with no keyway, and then you have the rotor. This is what holds the rotor blade on. It's just a friction fit, and that creates the downward force to create the friction. And it turns out they started seeing the cracking. The Navy, you're the corrosion leaders in the service. Okay, you are the #1 corroders in the service. If something's going to corrode, you will see it first. Okay, maybe the Coast Guard, but you'll see it first. The gray ones, that one hadn't cracked, but they found them still in their plastic wrappers from Sikorsky with cracks, stress corrosion cracks. We measured the residual stress by cutting that hole and measuring the thing very precisely before and after, and see how much the hole opened to expand. We estimated the residual stress of that at 8 KSI. That particular alloy, which was 6061 alloy, in the T6 optimum strength condition, has a stress corrosion cracking toughness, or yeah, it is toughness, of 5 KSI, which means 8 KSI residual stress, marine atmosphere, 5 KSI susceptibility, and we're right there in the middle of that little Venn diagram. And they would crack on the shelf without ever having been put in service. Well, the Navy noticed this. They told Sikorsky, and Sikorsky says, oh, you know, Sikorsky keeps their Black Hawk program separate from their CH-53 or MH-53 program, which is a different helicopter and different from some other helicopter. They said, oh, we saw this same problem in corrosion in one of our other helicopters on the same washer. Okay? And so we went to, instead of the T6 heat treatment, we went to the T7 heat treatment, which is overaged. What do I mean by overaged? Yeah, I got time for overaged. If I do precipitation heat treatment on aluminum alloy, I might as well do everything here. It's kind of the next stuff anyway. To heat treat an aluminum alloy, I take it up into this is aluminum copper alloy here. I take it up into the solid solution range, which is around 1,000 degrees Fahrenheit. I should say Fahrenheit, yep. And then I quench it down to room temperature in water typically. And I can't do air hardening like I do with steels. I usually have to quench it in water. And then I bring it back up to a tempering temperature. And the schedule might look like this. In fact, they quench in cold weather, so the solution heat for 1 hour at 940. They quench in cold water. They age for 10 hours at 340 degrees Fahrenheit. And they increase the strength. They can double the strength. Okay? And the doubling in strength looks like this, depending on whether they're in, this is centigrade, but I have another one. I'll put up the other one that's in Fahrenheit since we just had Fahrenheit. Same curves. Just someone likes to use Fahrenheit. And so it was 340. They basically were going to do 10 hours. Well, 10 hours at around 340, you can see you're going to get relatively high strength in 10 hours. They're probably using, well, I don't know what they're using. Anyway, they can go from this is hardness, so it's related to strength, from 65 up to 105 or 110 or something. Anyway, you can go even higher if you age for longer times, but who wants to do a heat treatment for 1,000 hours? Okay, that's a few months. So 10 hours is reasonable, so they they solutionize these things. If you go to the peak temperature, if I'm at 374, I'm doing my tempering, I can get the peak, that's a T6 heat treatment. I can lose 10% and go over, we call overaging, and lose 10% of my strength, but gain about a factor of 5 in corrosion resistance, okay? So what they had found is, Sikorsky, we did the T6 heat treatment on this other helicopter, we noticed problems with the cracking of the washers, you lose your tail rotor and you can have a bad day. In fact, the Army one killed 8 soldiers and put one of them in a coma in Arkansas. And that was actually later. Okay, first the Navy went and said, we have a problem. These are cracking on the shelf. Sikorsky says, we had fixed that on the other one. We went from T6 to C7. And they went out and they ordered 3,000 of those. Not 3,000, 1,300 of those. And they put them on order. It had been a year. They were going to be coming in 3 months, and they were going to change out the whole fleet, okay, all the services of the Black Hawk, okay. It turns out the Army had this failure in Arkansas, night vision goggle exercises and stuff, crashed, killed 8 people, and put another one in a coma, and it was a cracked washer due to stress corrosion cracking with a T6 heat treatment, okay. Now, it turns out, how do I get back to, why did I get off on this? It turns out, I've mentioned to you the government contractor's defense, that military hardware has been determined by the Supreme Court to be cutting edge technology, or some people call it bleeding edge technology. And you can relieve the stresses by stretching. We talk about the great big Alcoa plates, and they pull on the whole 6-inch thick plate to stress relieve it. So it's mechanical stress relief and tension. That's a T51 heat treatment, okay? You can also stress relieve in compression. That's in this case, it should have been a T62 heat treatment, okay, that they should have done. And it turns out, and Sikorsky's defense, when the people who had lost their lives in Arkansas were suing them, Sikorsky says, we have the government contractor's defense. The government approved the design of the Black Hawk helicopter, and therefore you can't sue us. We had to find a manufacturing defect. Well, the manufacturing defect is Sikorsky bought bars that were about 3 or 3.5 inch diameter that had been stretched, so it was T651. So it was a 6061 T6, which is the peak of the precipitation hardening curve, and the 5.1 on the end means they had stretched it. And so that 3.5 inch diameter bar had been put in a great big machine and stretched, and there are no residual stresses from the heat treatment, okay? Well then, when Sikorsky got it, they sliced it up like a bologna, and they machined the thing, and they reheat treated it. Well, when they reheat treated it, they wiped out the stretching that had relieved the residual stresses. They introduced new residual stresses on quenching, and they didn't do anything to relieve the residual stresses. Well, they said, well, we purchased it with stress relieved. Yeah, but then you reheat treated it, and you reintroduced residual stresses. This is sort of like the guys who said, we preheated that steel on Friday, and they're welding on Monday, right? Or it's like the guys at the jet engine company. Well, we put it into the furnace to diffuse out the hydrogen within 4 hours of getting the test report back 3 days later from the test lab. Okay. Oh, great. Okay. They didn't understand the physics or chemistry of what they were dealing with, and they had never stress relieved it. So I get the drawing that had been approved by the government, and it says that these washers are made out of T651. Yes, they ordered T651, they sliced it up, they reheat treated it. It was no longer T651. It had been T6, but they never did. How do you do a 5.1? How do you pull to stretch that washer to relieve residual stresses? Kind of hard to grip that thickness, or something that thick. What they could have done was a compression. They could have done a T62. So what they should have had was a T662. What the government approved was a precipitation hardened and stress relieved part, but what they had produced was not stress relieved, and that's why it cracked. The other news in all this is you need to know that the Black Hawk at the time was not only part of the Air Force, the Navy, the Coast Guard, and the Army, it was also the presidential helicopter. Okay? And so could have lost the president's helicopter because of this, this little engineering fiasco. Anyway, to show you the stretching and the stress relief, if you go to alloy 7050, which is actually the alloy which I believe they make the wings out of nowadays, not 7075, it's 7050 now, if I'm not mistaken. And this is a little cut sheet from Alcoa saying supplying the world's best. Comes out of their plant in Davenport, Iowa, which has the world's largest rolling mill. And actually I can show you this page first at the bottom. You can buy this as T7651, 7050 or 7075, which was what they used to use. You can buy it 2 to 3 inches thick. I'm sorry, that's in inches. And you'll get slightly better properties than the old alloy, but it's at 651 heat treatment, and elongation is actually a little bit better in this new alloy. And if we go to 7050 T7451, which is different heat treatment, which they use for even thicker plate, which is most of the wings, 5 to 6 inches thick, you don't get quite the strength, but it's still significantly better than 7075. Still got reasonable elongation and whatnot. So they're constantly tweaking the alloys because that extra 10% in strength means a 10% lighter structure, and that's important on aircraft. Okay. So I think the next topic, well, yeah, okay. Why don't we cut it there? We got to go to 3442. Who's presenting today?